Good morning, Algebra. I hope that we're having a great day and a great start to our week. We are almost to Thanksgiving, everybody. Almost there. Today's video is going to be all about the key features of graphs, things like domain and range, things about when the graph is rising versus when it's lowering, absolute minimums and maximums, relative minimums and maximums, everything's like that. It should be pretty straightforward. I think that you all are going to handle this no problem, but this video is here to help you as well. So, without further ado, let's get to the video.
All right, everybody. Today we're going to be talking about relations and key features of graphs. So by the end of this video, I hope that you're able to represent a relation and also interpret graphs of relations. So let's start with some key concepts and vocabulary, and this is going to be quite longer than what we have done in the past. So we're taking it all the way back to the basics. A coordinate plane is formed by the intersection of two number lines, and those two number lines are called the x-axis and the y-axis. The x-axis is the horizontal axis, think about horizon, flat, and then y-axis is the vertical axis, think about your vertical like you jump, how high you jump, so it's up and down. The origin is the point where the x and y axes intersect. We can represent the origin as the point 0, 0. An ordered pair names the location of the point in the plane, usually written as xy. So your x value, comma, your y value. And they have this nice little chart here to kind of show everything in a picture form. Now, a relation is a set of ordered pairs. The domain and range are something that are super important for this video and something you really want to take away from this. Domain is the set of all inputs. Gotta take that out. Something that is really important. Domain is the set of all inputs, your x coordinates. So it's all of your x values that you have in when you are graphing or when you are looking at a line, a graph, anything like that. The range is the set of all outputs, the y coordinates, all of your up and down points. I also want to point out two other key words that are going to be super helpful for you. The relative minimum slash maximum. The relative minimum or maximum is essentially the minimum or maximum in a small area, in a little window of your graph. It is not the maximum or minimum of the entire graph. Okay, the maximum or minimum of the entire graph overall is the absolute maximum or minimum. So you really want to look at the difference between relative and absolute. Relative means in a smaller area of my graph, just a little window, and absolute is the entire graph. And this is how we can kind of set up a relation, or just what we're going to be talking about. So we have our ordered pairs here. We have a mapping diagram. A mapping diagram essentially just tells us to essentially connect the points where they are. So I know that 0 is connected to 0, but 0 is also connected to -7. So I'm going to draw lines there. -1 is connected to 3, so I'm going to draw a line. 2 is connected to 5. -4 is connected to -2. And that's how I would do a mapping diagram. Now in a table, I literally just take all of my values and put them into a table. 0, 0, -1, 3, 2, 5, -4, -2, and 0, -7. And then you can graph it like I have done all the way on the right-hand side. I figured I'd just do that to save us a little bit of time, okay? But when we are graphing, we want to move our x value first. So for example, if I have 2, 5, that means I need to move 2 to the right, and then I need to move up 5 in order to get my point, okay? And we'll do another example like that in a second here. So we have another example. Express the relation as a table, a graph, and a mapping. So what I'm going to do is I'm going to take all of my points. I'm actually going to write them kind of in a ascending order, so from least to greatest. So -6, -4, -2, 1, and 5. And when I look at all of these x values, these are my domain. these are the domain of my graph. And then I need to look at my y values, so -1, 0, 1, 3, and 5. And then I need to do the same thing in a table form. 5, 0, -2, 5, 1, 3. That's a better looking 3. -6, 1, and -4, -1. Okay. My y values, that's my range. Okay. So now I need to take this into a graph. So I'm going to zoom in here to help make things a little bit easier. So I'm going to start with the point 5, 0, and I'm going to make my color red so that way I know. That means I need to move 5 to the right of my x-axis, because that's my x and this is my y. I need to move 5 to the right and 0 up or down. So 1, 2, 3, 4, 5. That's my final spot where I'm putting my dot. Now for -2, 5, that means I need to move to the left 2 and then up 5. So I move to the left 1, 2, then up 5. 1, 2, 3, 4, 5. Put another dot there. Make sure I erase the stuff in there because you are not supposed to leave the lines. You just need to put your dot. Then we have 1, 3. So 1, 1, 2, 3. -6, 1. So I need to go to the left 6. 1, 2, 3, 4, 5, 6, and then up 1. And then -4, -1, I need to go to the left 4 and down 1. So 1, 2, 3, 4, down 1. And that's what my graph was going to look like. Let's try some other examples. Determining domain and range. Okay, again, domain is all of my x values for this relation. Okay, so I essentially just need to look through my domain is going to be, and I'm just going to write it as D and R. So D, R. My domain are all of my x values, so 2, -1, -5, and 0. My range is 3, 5, 5, and -7. And in fact, since I have 5 twice, I actually don't need to write it 2 times when I'm writing out my range. I can just write it once. So you can see here, and I'll make this small for us too, my x values are my range, and then my y values, sorry, my x values are my domain, and my y values are my range. It is much easier with the table as well, because essentially what I can do is I can just draw an arrow and say that's my domain, and then my y values are my range. However, when it comes to a graph, that's when I have to look carefully, okay? So that means I need to label all of these points in order to try to figure out what they are. So I'm going to zoom in. So I'm just going to go through point by point and label what these points are. So I have 1, 2, 3, 4, 5, 6, 7. So this is 7, -2. 1, 2, 3. 1. So this is 3 to the right. 1, 2, 3, 4, 5, 6, 7. 7 down. This is 2 to the right. Then up 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3 to the left, so -3. 1, 2, 3, 4, 5, 6, 7. -3, 7. And then this point all the way on the left is 1, 2, 3, 4, 5, 6, 7 to the left, -7, and then up 3. So now I need to work on my domain and my range. So I'm going to put D. My domain is 2, 3. Let's see, 2, 3, -3. So let's see, I'm just going to go through and check mark 2, 3, -3, -7, and 7. And then my range is going to be -7, -2, 3, 7, and 8. Now, when it comes to trying to find my range for graph D, I need to look carefully. I see that there are arrows on both sides or on both ends of my line. That means that these numbers or that these arrows are continuing on forever and ever and ever. And it looks like it's going to keep going all the way to the right for forever and all the way to the left for forever. It also looks like it's going all the way up for forever and all the way down for forever. So in fact, for my domain and my range, so I'm going to put D and R for both of them, it's all real numbers. Any number that you can think of that is real, in fact, I'm just going to put a hashtag here. Any number that you can think of will be a possible x value and will also be a possible y value. So I've got a couple more examples here. Let me zoom out here. In this last example, I'm just going to do part 1. What are the variables? Describe what happens in the graph. So the first graph, A, the graph shows the volume of air in a balloon as Alyssa blows it up until it pops. So this is where it's really important for us to kind of look at the graph and section it off. I see that my variables are volume and time. But it's also important for me to look at when it's increasing versus when it's staying the same or decreasing. Okay, that's another part that I need to look at when we are assessing graphs. So I see that it's increasing here, staying the same, increasing, staying the same, increasing, staying the same, increasing, and then a dramatic drop. Okay, and then we need to take that next step and think about what this is possibly trying to describe. Well, in this case, I'm going to say that when the graph is increasing, she's blowing up the balloon, the volume is getting larger. When the graph is flat, the balloon isn't growing anymore, it's not gaining any more volume, so maybe she's breathing. And when the graph drops, I'm going to say that the balloon is popped and there's no more volume that is left. Okay? So that's just an example of how we would approach that kind of problem. Okay? But those are all the examples that I have. So if you have any questions, please feel free to leave a comment in the comment section below, or you can message me on Schoology. But I hope that you have a great rest of your week, and until next time, I hope that you have a great day.